let's just move on towards our new topic, which is nothing but called as the remainder theorem. But before starting the remainder theorem, let us suppose we are talking about the general division or the division of two numbers. So let us suppose I'm taking a scenario over here that we do have two babies, blue baby and pink baby, and I do have 5 cookies with me. So the experiment is like we have to divide these 5 cookies to these two babies in an equal amount. So it means that हमें 5 cookies को 2 babies में इस तरीके से divide करना है कि दोनों को equal amount of cookie मिले, with a condition कि cookie को break नहीं किया जा सकता. आपको whole cookie जो है वो दोनों babies में divide करनी है. So let us suppose I'm starting with the very first cookie and I'm giving this cookie to the very first baby and then to the pink baby. Again we are dividing the cookie as I'm giving the second cookie to the blue baby. Further I'm giving the next cookie to the pink baby. So both of them now do have equal amount of cookies with each other, and there is one cookie which is left over, and इस cookie को मैं दोनों के बीच में divide नहीं कर सकती क्योंकि condition क्या थी? Condition थी कि एक cookie को आप break नहीं कर सकते हो, आपको उन्हें whole ही देना है. तो अगर इस scenario को मैं mathematical world में represent करना चाहती हूँ तो मैं किस तरीके से करूंगी कि let us suppose we do have 5 cookies with us. So 5 cookies की representation थी हमारे पास और हमें 2 के बीच में divide करना था, that is blue baby and pink baby. तो हमने किस तरीके से divide किया? 2 into 2 is nothing but 4 and we are getting the remainder as nothing but 1. So the scenario is like we do have 5 cookies, we have to divide these 5 cookies in between the 2 babies, and we have divided the 5 cookies as both of them are getting 2 equivalent amount of cookies, and at the end what is the remainder? Remainder is nothing but the first cookie or the one cookie that we do still have with us. So let us suppose we are talking about this division. So let us suppose we are talking about this division, as we know that each and every number over here do have its own representation or its own name. As first of all, let us suppose I'm talking about this 2. This 2 is nothing but called as the divisor. 5 can be called as nothing but the dividend. 2 is nothing but called as the quotient, and 1 is called as nothing but the remainder. So this is a divisor, dividend, quotient and remainder. Now this is all about dividing two numbers altogether. Now the question arises over here. The question arises that whether we can divide one polynomial by another, because we have divided two numbers over here. Now whether we can divide two numbers with each other, two polynomials with each other or not. So let us suppose I am considering two polynomials as 2x cube plus x square plus x, and we have x another polynomial, so we are dividing both of these polynomials. So let us suppose I am writing it as 2x cube plus x square plus x, and x as or we can say x is existing as a denominator of each and every term of the polynomial. So using the laws of the exponents, what we can say, if the variables do have the same base, if the variables x cube and x have the same base, then their powers will get subtracted from each other because they are in the form of p by q. So after using the laws of the exponent, we have concluded that at the end, by dividing the two polynomials, what we are getting 2x square plus of x plus of 1. So at the end, what is the conclusion? The conclusion is that the x polynomial and 2x square plus x plus 1, they are nothing but called as the factors of 2x cube plus x square plus of x. So it means that we can divide the two polynomials altogether, and at the end what we can say, the values x and 2x square plus x plus 1, they are nothing but called as the factors of the given polynomial, that is 2x cube plus x square plus of x. Now let us suppose we are taking another example or a question in which we will learn how we can divide two two polynomials altogether. So let us suppose I am now dividing px polynomial with the gx polynomial as, so let us suppose we are start dividing the polynomials px and qx. So first of all, in order to divide the two polynomials, there are some steps. So let us suppose I'm talking about the step number 1. Step number 1 says arrange. Step number 1 says arrange both the polynomials. Arrange both the polynomials in the descending order of their exponents. You have to arrange both the polynomials in the descending order of their exponents. What is the meaning of that? Let us suppose we are talking about the px polynomial. So px polynomial was x plus 3x square minus of 1. So we have to write them in the descending order of their exponent. So let us suppose I am writing the very first term which do have the highest power or the highest exponent as 3x square, and after 3x square we have x term which do have the power as 1. So we have to write them in the descending order. So it would be like x minus of 1. So hence px is equal to 3x square plus x minus of 1 is written in the form of the descending order of their exponents, because the power over here is 2, further the power of x is 1, further the power of x over here is nothing but 0. So this is nothing but called as the arrangement of the polynomial in the descending order of their exponents. Now in the same pattern we have to arrange g of x. So g of x can be written as x plus of 1. Obviously, again further, the power of x over here is nothing but 1, and if we have 1, we can write it as 1 into x raised to the power 0. So obviously this is nothing but the descending order of their exponents. Now the step number 2 says, this is our step number 1. Now let's just talk about our step number 2. What is the step number 2? So step number 2 says divide. Step number 2 says divide the first term of px by the first term of gx in order to get the first term of the quotient. What is the meaning of this step? So let us suppose I am representing it in the form of division or in the form of dividing p of x with the g of x as. So let us suppose I am writing g of x as x plus of 1 as nothing but a divisor. Further, I am taking p of x as nothing but the quotient, a dividend. So it would be like 3x square plus of x minus of 1. So obviously this is my divisor, this is my dividend. So the step number 2 says divide the very first term of 3x square with the very first term of x, that is divisor. So let us suppose I am dividing over here. So I am dividing 3x square with the term x. So it is nothing but x raised to the power 1 over here. So we can write it as 3x raised to the power 2 minus of 1. So obviously this is 3 of x. So 3 of x is nothing but the first term of the quotient. It is nothing but the first term of the quotient. So we can write 3 of x over here. 3x is nothing but the first term of my quotient. So step number 3 would be like multiply 3x, that is the first term of the quotient, with g of x and subtract the result or the resulting polynomial, subtract the resulting polynomial from P of x. From P of x. So it means that we have to multiply 3 of x with the whole divisor. So 3 of x when get multiplied with the 3x plus 1, what we will get? We will get 3x into x plus 1 means 3x square. 3x will get multiplied with the 1, so we will get plus of 3 of x. So the step number 3 says multiply 3x with g of x. So when we have multiplied 3x with g of x means x plus 1, we are getting the result as 3x into x is 3x square, 3x into 1 is nothing but 3 of x. Always remember to write the resulting polynomial, this resulting polynomial into the form of again descending order of their exponents. So I am writing this as a descending order of their exponents. So now just subtract 3x square plus of 3 of x from the given P of x polynomial, that is 3x square plus x minus 1. So the step number 3 says subtract both of these all together. So let us suppose I am subtracting them. Obviously 3x square and 3x square will get cancelled with each other, so we are getting the value as 0. But over here we are actually subtracting these terms. So let us suppose I am writing the subtraction sign over here as we are subtracting. So let us suppose I am writing a minus sign over here. So here we have a positive sign as we are subtracting. So let us suppose this is nothing but a subtraction sign as we are subtracting. So in place of plus we are taking minus, because plus minus is obviously minus, and after subtracting both of these we are getting the answer as 3x minus of x is nothing but 2 of x, and the sign would be like minus because obviously minus of 3 is greater than this particular value. So hence at the end after subtracting these two terms, what we are getting the answer as nothing but minus of 2 of x, and further take the remaining value as minus of 1, as minus of 1. So at the end after subtracting these two terms all together, we are getting the remainder as minus 2 minus of 1. So the next step would be like, the next step, that is step number 4, would be like the remainder in the step 3 is the new dividend, and repeat the whole steps again, with the new dividend. So let us suppose minus 2x minus 1 is now our new dividend, so we have to repeat the whole steps again with this dividend as this is our new dividend. So we have to divide the first term minus 2 of x with the very first term x. So when we will divide minus of 2x with x, what we are getting x and x get cancelled with each other, we are getting minus of 2. So minus of 2 is the second term of our quotient. Now the next step would be like, we have to multiply minus of 2 with the whole term again. So when we will multiply minus of 2 with the whole divisor again, so it would be like minus of 2 of x, and plus minus is minus, so this is nothing but minus of 2. Now again we are doing a subtraction over here. So this would be like as we are subtracting both of these terms, so this would be like minus would be changed into a plus sign and negative would be changed into a plus sign again, because as we are subtracting both of them, so minus and minus would be plus and minus would be plus. So hence at the end what we are doing over here, minus 2x and plus 2x get cancelled out with each other. So at the end what we are getting plus 2 and minus 1. So plus 2 and minus 1 is nothing but obviously plus of 1. So at the end what we are getting the remainder as nothing but 1, which is our remainder, and this is nothing but our divisor and this 3x square plus x minus 1 is nothing but our dividend, and 3x minus 2 is nothing but our quotient. So we can write whole this formation into the very special form, as we know that dividend is always is equal to divisor into quotient plus of remainder. This is the general representation, as we know that dividend can always be written as divisor into quotient plus of remainder. So we can write this formation as the dividend that we do have is nothing but of the form 3x square plus x minus of 1. So we can write 3x square plus of x minus of 1. It is nothing but is equal to divisor into quotient, that is nothing but x plus 1, that is nothing but x plus 1 into 3x minus of 2, and the remainder at the end what we are getting is nothing but 1. Always remember, we will always get the remainder whose degree should always be less than the degree of x plus 1. Always remember the fact that the degree of the remainder, let us suppose I am writing it as note, the degree of the remainder is always less than the degree of divisor. The degree of divisor. So let us suppose in general I am writing it as we know that this representation was called as g of x. This representation was called as g of x, and this representation was called as p of x. This was called as p of x. Let us suppose I am calling it as q of x, and I am calling it as r of x. So we can write this particular formation as p of x is equal to g of x, q of x plus r of x. We can write in general that p of x is nothing but is equal to, in general we can write p of x as nothing but is equal to g of x into q of x plus r of x, with the condition that the remainder or the degree of the remainder is always less than the degree of the divisor. So this is all about, or this is the algorithm of all about dividing a particular polynomial with another polynomial.